Good day, everyone. I will discuss to you the application development life cycle. First, I will tackle an overview of what web application development is, and second will be the methodologies useful in development. Although this is a sort of review, since you may have experience developing some of your previous projects, it is still essential for us to recall why do developers need methodologies in developing applications. Let us start in defining what website is versus what web application is. By definition, a website is a collection of web pages. For example, Google. Their search engine is essential in exploring information, may it be homework or just random things you can think of. Searching terms directs you to any other pages. These pages are the result of the topic related to what you are looking for. That is why it is a collection. It consists any other pages. Websites is also one of the most powerful tool for communication because it is a unique way to connect with the world. Whether you choose to create a website to share your passion for music, inform people of your business, sell products, or in any other reason, there are no boundaries to what you can do. While a web application is an application that can be accessed through a web browser. Application consists of frameworks that are set of program libraries, components, tools, organized in an architecture system, allowing developers to build and maintain complex web application projects using a fast and efficient approach. Thus, website is a result rather of the application we want to develop that your end users are actually using it. So I may say that a website is a part of the whole application development. As to the web features, website consists the following: the client server, which denotes a computer system in which work as a central server. It provides data to a number of network workstations. So here, in your client device, so you may need a URL address where you can input it to access a specific web application to the web server. So your system here and your web server now here has a computer program that is responsible for accepting HTTP requests from clients and serving them HTTP responses, or it stands for Hypertext Transfer Protocol. HTTP is the underlying protocol used by the WW or the World Wide Web, and this protocol defines how messages are formatted and transmitted and what actions web servers and browsers should take in response to various commands and display the result to your device in a form of web or HTML pages. So the application can be accessed from the server port that consists of program libraries, components, and tools organized in an architecture system. So, example for this one, it uses a Java programming language. Its components extends the capabilities of a server with the use of servlets. Although servlets can respond to many types of requests, they most commonly implement web containers for hosting web applications on web servers and thus qualify as server-side servlet web API. So you may consider this one as a whole container in where you store everything you needed in your application. So from your classes, do the different files you need, the different classes, front-end codes, your database codes. So consider this as a container. And this one using the browser, so you may input there the URL address that would automatically access your HTTP server, or with what we call as port. In its architecture, we may represent it as layers. So we have here the client side as the first tier that is responsible for the presentation logic. So this takes input from the clients or your end users. And in order to access the applications, we may be familiar of some of the web browsers like Opera, Camino, IE, Safari, Firefox, Flock, Conqueror, SeaMonkey, and lastly, the famous one, Google. So each of these web browsers have different rendering engines, or it could have also different JavaScript engines and CSS engines. But notice that not all application is applicable to any engine. So that is why it is important to note which web browser do you want to deploy or access your applications later on. So the second tier of the architecture is the server side. So it is responsible for business logic and business rules of the system. Servers could be powered by an Apache or IIS, or Internet Information Services by Microsoft. So if you prefer to use PHP or Python, so you may encounter Apache a lot here. So servers are responsible also in accessing your database or your storage. So to be able to connect with the server, it is important to study some programming languages like Java, Perl, Python, ASP.NET, PHP, or CGI. As the server side hosts the computer program, it is responsible for accepting HTTP requests from your clients or your user agents such as web browsers, and serving them HTTP responses along with optional data contents, so which usually are web pages such as HTML documents and link objects, images, etc. So your web programming languages might be able to access all of that, so it will serve as a tool for you to collate everything so you can make your applications work. So the last tier will be the database side. So it serves as a container of the data, and here you need to know the basic functions in managing your data, such as create, read, update, and delete. So you can access the database through the server side. And you might also be familiar with some web containers. So there are actually two types of web containers: the non-commercial or open source and the commercial. So if we say open source, this is free for all. That's why if you use Python, PHP, so they usually use Apache Tomcat. So it is a beginner friendly in creating your own web applications. So these commercial web containers here are of course not for free, so you might be able to pay for a plan or pay for how many months you would be able to use it. So as in our methodology as a review, so we define methodology as a framework that is used to structure, plan, and control the process of developing a software or an information system. So this usually deals with the process of planning, creating, testing, and then deploying a project. So it is important for us to recall this one also, as this will serve as a guide for us to be able to complete or to be able to achieve the objectives in our project. So software development methodologies are Waterfall model, prototype, agile, RAD, DSD, spiral, extreme programming, feature-driven development, JAD, lean development, Scrum, and V model. So I won't be able to discuss all of this. I will just choose some as a review on each of the phases. So first one, we have here the waterfall model. So the waterfall method is the process. So you can see the process here is a linear flow with a specified sequence to let the users understand that further level is made progressive on completion of the previous one. So as you can see, you may represent it as stairs, also a phase-by-phase approach. Waterfall model is sequential in nature. So usually the advantage of this is that it is easy to understand and functional because it is simple enough to handle as a model is rigid. So of course, you can save significant amount of time for this one because you have to finish one by one. But the disadvantage of it, if you need to go back to certain phases because you might have requirements, so it does not actually allow editing on the previous phases that you are actually done. So you have to be sure that it matches the precise needs in each phases because there are no option to know possible outcome of a project. Although it allows us for easy testing and analysis, once each phase are done, you may not be able to go back to any other phases. And the second one will be the prototype. So a prototype is an early sample of model or release of a product built to test the concept or process. So it is a specialized software development procedure that initiates developers towards making only the sample of the solution. So to validate its functional essence to the customers and make essential changes before creating the authentic final solution. So we will discuss this more when you go through your project. It is a term used in a variety of contexts including semantics, design, electronics, and even software programming. So as you can see, in each of the phases, it starts with empathizing, understanding your customers, defining the sweet spot or defining the needs of your customer, then ideate, so analyzing what your customers needs, and prototype, creating an early sample or model of the product you are creating, and test, knowing whether it has still some room for improvement. The advantage of this is that it gives clear idea about the functional process of the software and it reduces the risk of failure in a software functionality because it assists well in requirements gathering and the overall analysis. But of course, one disadvantage of this is that you may need excessive involvement of the client that can affect also in the process because again, too many changes affects the workflow of the software. And another will be the V model. So it is an SDLC model where execution of processes happen in a sequential manner. In a V shape, it is also known as verification and validation model. The corresponding testing phase of the development is planned in parallel. So there's a verification phase on one side of the V and on the other side of the V is the validation. So the coding phase here actually joins the two sides of the V model since each functionality you develop needs to be tested right after, or we call that as unit testing. So for every single phase in the development cycle, there is directly associated testing phase. So the advantage of the V model method is that it works well with smaller projects where the requirements are very well understood, and it is highly disciplined model and phases are completed one at a time. So simple and easy to understand and use. But somehow, the disadvantage of the V model method is that it is not a good model for complex and object-oriented projects. So it is not suitable for the projects where the requirements are at a moderate to high risk of changing. And once an application is in the testing stage, it is difficult to go back and change the functionality. Another will be Agile. So this is used for articulating a well-organized project management procedure, allowing for recurrent alterations. So certainly, such type of a methodology is one theoretical outline for undertaking several software engineering projects. So if you guys can observe from the waterfall model, since it doesn't allow us some changes on the previous phases, so here in Agile, it actually minimizes spiral by creating software in short time boxes. So these are known as iterations, so which happen to last from 1 week or to 1 month depending on the duration of the project. So some advantage of this is that it is an adaptive approach that responds to changes favorably, because it allows you to go back to any other phases if you are not still satisfied with the result of it. Some disadvantage of this is that it focuses on working with software and lacks documentation efficiency, because from time to time you have changes in the development phase, you will also have changes in the documentation. So chances are you might get off the track as outcomes are not clear. And this one, a spiral model, so this is actually one model that represents agile or those time boxes iterations. So being a highly sophisticated design, it is meant to reduce the early risk in the project. So the accomplishment of this spiral is based on the consistent, observant, and conversant management of the project. So this is actually excellent for large and complex projects. So in each of these quadrants, you may assign this to phases. So here we have the initiation, design phase, develop, testing. So as per process going by, the developers initiate on a smaller level and explore the included risk in it. So further to this, the developers are intended towards crafting a plan for iterating of the spiral. So some advantages of this are it allows for additional functionality later, and it is suitable for highly risky projects with varied business needs. So this is a costly model, but it is excellent for large and complex projects. May not be applicable to all projects because it might get continued but it never finished because it's a never-ending process. Also, we have here the Scrum development. So this initiates with a brief planning conference and completes with a concluding review. This growth of methodology is used for prompt development of software that happens to include a series of iterations to generate the required software. So it is a perfect approach because it effortlessly brings you on track. So the goal of the Scrum methodology is to improve the productivity where progress is halted. So one of the key features of the Scrum include the creation of a living backlog of work sorted by priority to be completed in sprints or iteration. So these sprints here also have um, different objective and different priorities. And once it is already done, so you will have to track it electronically. So reflect whether you still have items that may have problems, and then it allows meetings or communication with the team, and it goes back again to your backlog and setting the priorities again and again. This is one of the most important thing to consider when developing the web applications. So first, how do you manage the requirements? So with the life cycle, requirements gathering and analysis is the crucial part. So this phase is used to translate the imprecise, incomplete needs and wishes of the potential users of the system into complete, precise, and formal specifications. And note that specifications, whether it be functional or non-functional, the specifications act as the contract between the software users and the developers. So therefore, the importance of requirements engineering is enormous to develop effective software in reducing errors at the early stage of the development.